So today we're going to look at beginning to add and subtract fractions. So these little portions of a whole that we've been talking about, we're going to see what it means to actually work with these and how they differ from whole numbers. So giving just one example here. I have a half plus a half. Now, from what I know with addition, I know that when I add things together, then I'm just I'm just going to work through and I'm going to look at this and I'm going to just add everything I see, right? Like, why not? So I'm going to add this. I'm going to say, okay, well, this gives me 2 over 4. And okay, I can simplify this and, seeing that the top can be divided by 2, the bottom can be divided by 2. All right, well, that gives me a half. This type of sense check here is what gives us the intuition that something here has gone wrong. So the rules of addition, subtraction, multiplication, and division of just whole numbers together, compared to if I did 1 plus 1 or 2 plus 2, it changes when we look at fractions, because you can't tell me that, well, I've added a half and another half, and that gives me a half. So something has gone wrong here. Let's see what it was. Now, we look at fractions as some portion of a whole. So let me draw here one circle for you. And, well, actually, no. I'm going to draw 2 portions here. I'm going to draw one semicircle here and another semicircle here. Now, a semicircle is essentially half of a circle. So it is 2 portions of a circle. So if I were to add these together, right? So I'm going to put a plus sign. I would combine these, right? I'd add my one portion to the other portion. So I'd kind of close these in together and I would end up with one whole. Now, it's kind of weird to look at this visually because, well, I've written this down, but how do I show that? How do I show that mathematically? I've shown it visually that, well, okay, I know something's been split into 2 equal bits, and both of those make up one half. When I add one to the other, it gives me a whole. Well, it essentially gives me one whole. Now, mathematically, I'm going to rewrite my expression here. Half. This is essentially when I put these together, and when I've added these together, that gives me essentially 2 halves, doesn't it? So I get 2 halves over my original 2 portions that we split this circle into. And 2 divided by 2 just gives us 1. Now, say I cut this, let's just call this a pizza, right? So let's say I cut this pizza up into 4 slices. I wanted to give these to a friend of mine. So I have a quarter of a pizza, and I'm actually going to write this down. So this makes up my 1/4. So essentially 1 piece out of the total 4 that this has been broken up into. So essentially 4 of these slices make up an entire whole. But we just have one portion of this, so it's 1/4. Now, say one of my friends is full, he ate earlier, and he's going to give me his half. So he gives me this half as well. Now, we can visually see that my piece that I originally had, plus my piece that I acquired, the piece that my friend gave me, make up half of my circle. So let me actually explicitly draw that in another color. It's made up half of my circle here. I have this whole thing here, as opposed to my empty space there. So, all right, well, visually and intuitively, that hopefully makes sense. But I'm going to write down sort of the mathematics, and with all of these, I'm going to see if you can figure out a certain trend that's happening, some kind of pattern that we've made here. So I have 1/4 that I have, and the 1/4 that my friend gave me. So this means I've added my 2/4. And the answer I end up with, I'm going to go one step ahead. Well, the answer I ended up with was a half. But what makes up a half here? Well, what makes up the half is essentially just a simplified version of 2 of my 1/4 portions out of the total 4 portions I have in my pizza. So, could we then say that, all right, I have my portion and my friend's portion. Now I have 2 portions of the pizza out of the total 4 that I could have had. Now, this is adding, for example, right? I'm still not going to, hopefully you're seeing some things come together, but I'm not going to explicitly define this just yet. I'm going to give you one more example with subtraction, however. So, make my purple, have my purple pizza again here. And this time I'm with a bunch of people. So we're going to split this up into, that's shocking. I'm not very good at drawing, if you've gotten the idea by now. Now, say we have 8 equal portions here. Now, let's say that I originally had, between the few friends that I got together for this party and we ordered pizzas, and I originally had 3 pieces to myself. I went to this pizza and I grabbed my 3, and then suddenly I decided that I kind of ate earlier. I'm not too full. Let me give one of my portions away. So all of these, for example, first make up 1/8 of my pizza. So I've divided into 8 separate pieces, and each of these proportions is 1 out of these 8. So what I have, well, I can say 3/8 to start off with. The portion I have is 3/8. Now, I'm full, right? So I'm going to give away one of my 8ths to a friend. So I'm just going to shade this in a different color. Let's pick one I haven't done before. Let's go yellow. And I want to give this away to a friend. So I'm discounting this from what I have. So I'm just effectively taking 1/8 away from my 3/8. Now, I've given this away, and let me actually just rub this out. So I've oh, I've given 1/8 away, so I'm left with 2 portions here, excluding the one that I gave away, so this one here. Now, what am I left with? Well, I only have 2 out of the whole 8 that are there. So essentially, I'm left with 2/8, which, I mean, we know mathematically, this simplifies to the equivalent fraction to 2/8. 2 can go into the top and bottom. So we can divide both top and bottom by 2, and this gives me a quarter remaining. Now, how can I show a quarter up here? Well, it's been split into 8 bits. But what if I, well, got rid of this line here? And, sorry, I still have my shaded bit. And I got rid of this line here. We still have, well, we have 1, 2, 3, 4. And I have 1 of these. So this is an extra kind of visual representation of the equivalent fractions and the process of simplifying fractions that we talked about before. So that is essentially what we notice. And if you picked up on the kind of mathematical procedures, we always kept the denominators the same. The denominator was always constant, and we did the operations just in the numerator. These numerators are the portions of the whole we get. So we added 1 plus 1, that gave us 2 over the 4 we had to start with. Here we added 1 and 1 over the 2, which stays the same. So that, overall, is how we add fractions with the same denominator. And we'll work at adding ones with different denominators in the next video. See you there.